Hello students, welcome to Darasa Online. My name is Edgar Mshana. I'm teaching basic mathematics. Today with the topic of circles, we are going to discuss some theorems which are in angle properties of a circle. So students, join with me till the end of this presentation. Welcome. So now let us start with the first theorem of angle properties. And the theorem states that the angle that an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Here we have a circle with the center O. There is the angle at the center of this circle and some angles in the circumference of the circle. According to our theorem, the angle at the center is double angle at the point of circumference. Now let us prove this theorem. So students, consider this construction of the circle with the center O. Now, in this case, we are going to consider the triangle ABO so that to prove our theorem. So here we say using the triangle ABO. Now, this is an isosceles triangle, whereby the base angles are the same. Now, in this case, we say angle OAB plus angle ABO, then plus angle BO. This is equal to 180 degrees. Sum of angles inside of the triangle ABO. But remember, OAB is the same as ABO, base angles of the isosceles triangle. So in this case, we have XC plus XC plus BOA. This is equal to 180 degrees. Now let us make angle BOA the subject. That is BOA. This one is equal to 180 degrees minus 2x. That is x plus x is equal to 2x. Now this is equation 1. But again, students, there is a straight angle here. That is BOA plus AOR is equal to 180 degrees. Sum of angles in the straight angle. So in this case, we say angle BOA plus AOR. This is equal to 180 degrees. That is the straight angle. Now again, let us make BOA the subject. That is BOA. This one is equal to 180 degrees minus AOR. Now call this equation 2. Now in this case, we are going to equate these two equations. So that is equating equation 1 and equation 2. So in this case, we have 180 degrees minus 2x. This is equal to 180 degrees minus AOR. So in this case, we can simplify our equation by 180. Then we remain with negative 2x this one is equal to negative a or r. So I will say a or r is equal to 2x. But again, remember, a or r is equal to a. Therefore, we say a is equal to 2x. So we say hence proved. It is hence proved. Now remember, a is the angle at the center, and x is the angle at the circumference. So that is how to prove this theorem. Now students, let us do some examples concerning to the first theorem. So students, here we have our example. We have 3 circles. We are supposed to find angles labeled with letters in the following circles. Now let us start with the first circle. Now for A, there are some angles at the center, that is A and B are the angles at the center, while that is the angle at the circumference. Now in this case, remember, angle at the center is double angle at the circumference. Now in this case, we say POQ, that is equal to twice PRQ. That is POQ is the angle at the center of the circle, while the PRQ is the angle at the circumference. Therefore, POQ is the same as A. That is A is equal to 2 times PRQ. In that case, is equal to 30 degrees. So we times by 30 degrees. Therefore, A is equal to 60 degrees. So that is for angle A. Now for B, remember, sum of angles at the center of the circle is equal to 360. So in this case, we say A plus B, this is equal to 360 degrees. That is the sum of angles at the center of the circle. Now remember, A is equal to 60. Therefore, we have 60 plus B is equal to 360 degrees. So B is equal to 360 degrees minus 60 degrees. Therefore, B is equal to 300 degrees. Then students, let us proceed with B. This time we are supposed to find angle X and angle Y. So that is B. Now remember, the sum of angles at the center of the circle is equal to 360. So in this case, we say XC plus 160 is equal to 360 degrees. That is sum of angles at the center of the circle. Therefore, XC is equal to 360 degrees minus 160 degrees. Therefore, XC is equal to, that will be 200 degrees. That is angle XC. Now again, we are supposed to find angle Y. That is the angle at the circumference. Remember, angle at the center is double angle to the circumference. So in that case, we say XC, that is XC is equal to 2Y. That is angle to the center is double angle to the circumference. But remember, XC is equal to 200 degrees. So in this case, we have 200 degrees is equal to 2Y. So divide by 2 from both sides. Then we have Y is equal to 100 degrees. So that is B. So students, I hope we are together. Now let us proceed with C. Now this time, there is an angle at the circumference which is equal to 40 degrees. And again, there is angle Z which is in an isosceles triangle. Now remember, angle to the center is double angle to the circumference. Now it is possible to find angle A or B. So in this case, you see, we say A or B is equal to double A, C, B. So A or B, this is equal to 2 times 40 degrees. So in this case, A or B, now this one is equal to 80 degrees. So students, in this case, angle A or B, which is this one, now we have 80 degrees. Remember, A or B is an isosceles triangle, whereby the base angles are the same. So we say, now using the triangle A or B, which is an isosceles triangle. So in this case, we say O, A, B, then plus A, B, O, again plus B, O, A. This is equal to 180 degrees, sum of the angles in the triangle. So, but OAB and ABO are the same. So this one is Z, then plus Z, then plus BOA, which is 80. This one is equal to 180 degrees. So in this case, we have 2Z is equal to 180 degrees minus 80 degrees. So 2Z is equal to 100. So in this case, divide by 2 from both sides. Then we have Z is equal to 50 degrees. Now student, let us proceed with the second theorem. So this is our second theorem, which states that angles in the same segment of a circle are equal. So here we have a circle, and the angle AUB, and the AVB, and the AWB. These angles are in the same segment of the circle. Now these angles, according to this theorem, are the same. Now let us prove this theorem. So students, this is the construction of our circle. Remember, our interest is to prove that APB is equal to AQB. Now, in this case, remember, angle at the center is double angle at the circumference. So in this case, we say, it is proof. We say A, O, B. This one is double A, P, B. Remember, A or B is the angle to the center, while APB is the angle at the circumference. So angle to the center is double angle to the circumference. Now this is 1, but again A or B, this one is equal to 2AQB. So again, the same reason. A or B is the angle to the center, while AQB, which is this one. So students, R or B is equal to 2AQB. That is, R or B is the angle to the center, and AQB is the angle at the circumference. Now students, we have two equations. Now let us again equate the two equations. So we say equating equation 1 and 2. So in this case, we say 2APB, this one is equal to 2AQB. That is according to the two equations. So in this case, we can simplify our equations. So we remain with the APB. This is equal to AQB. So now it is true that angle APB is equal to angle AQB according to our theorem. So students, let us do the review question concerning to this theorem. So students, this is our question. That is, find the angles marked by letters in the following circle where O is the center of the circle. So here we have three letters, A, B, and C. Now remember, angle T, Q, O is the same as angle T, R, W, and again the same as angle T, SW. Why? Because they are in the same segment of the circle. So in this case, students, we say that is angle A is equal to B is equal to 40 degrees. Why? Because these angles are in the same segment. Therefore, A is equal to B is equal to 40 degrees because they are in the same segment of the circle. Now we proceed with C. Now in this case, we are going to use triangle TRM. So we say using triangle TRM. So in this case, the sum of angles remember here we have 60 degrees. Remember the sum of angles in triangle TRM is equal to 180 degrees. So in this case we say that is OTR then plus TRM then plus RMT. This is equal to 180 degrees. Why? Because these are the sum of interior angles of a triangle TRM. But the angle OTR is equal to 60 degrees and the TRM that is equal to 40 degrees. So in this case we have 60 degrees then plus plus 40 degrees then plus RMT. This is equal to 180 degrees. So now we are going to find angle RMT. So RMT in this case is equal to 180 degrees minus 100 degrees. That is the same as 60 degrees plus 40 degrees. So RMT, this is equal to 80 degrees. So in this case, dear student, angle RMT, which is this one, is equal to 80 degrees. But again, students, angle RMT, which is this one, is the same as angle SMW, which is this one. These are the opposite angles. So in this case, SMW is equal to 80 degrees. So again, we say using triangle SCMW. So in this case, we say SCMW plus MWS then plus WSCM. Again, this is equal to 180 degrees. So remember, angle WMSC or SCMW is equal to 80 degrees. So here we have 80 degrees, then plus, remember, WSM, that is B, is equal to 40 degrees. That is equal to 40 degrees, so plus 40 degrees, then plus angle C, this is equal to 180 degrees. So 80 degrees plus 40 degrees, that is 120 degrees, then plus C is equal to 180 degrees. Therefore, C is the same as 180 degrees minus 120 degrees. Now, on subtracting, now we have C, angle C is equal to, that is 60 degrees. So again, I hope we are together following this lesson where we are discussing the angle properties of a circle. Now let us proceed with the third theorem of a circle. So dear students, the third theorem states that the angle in a semicircle is a right angle. Now again, let us see in this figure 6, we have a circle with the center O. According to this theorem, angle AXB is equal to 90 degrees, is a right angle because it is generated in a semicircle. It is formed in a semicircle. Now again, let us prove this theorem. Now students, consider a circle with the center O. Now in this circle, we say given we have a circle with center O. And again we have a triangle AXB inscribed in this circle. So again here we have a triangle, that's a triangle AXB, that is inscribed in the circle. Now remember, our intention is to prove that angle AXB is equal to 90 degrees. So in this case we say to prove that AXB is equal to 90 degrees. That is what we are supposed to prove. Now, our proof is as follows. Now remember, angle AOB is a straight angle, which is equal to 180 degrees. So here we say AOB, this is equal to 180 degrees. Of course, this is a straight angle. That is a straight angle. But also students, angle to the center is double angle to the circumference. That is AOB, which is at the center of the circle, is equal to twice AXB. That is angle at the center is double that at the circumference of the circle. Now we have two equations. Now again, let us equate these two equations. So on equating these equations, now we have 2AXB. Now this one is equal to 180 degrees. Now let us divide by 2 from both sides. So we have AXB, this is equal to 90 degrees. So in this case, we say hence proved. Now according to this theorem, it is true that angle formed in the semicircle is equal to 90 degrees. It is a right angle. So students, we have a review question that is, find the angles marked by letters in the following circles, where O is the center of the circle. So here we are having two circles, that is A and B. Now we are supposed to find angle A, but also angle B. So students, starting with A, that is A. Now remember, PQR is equal to 90 degrees because it's the angle formed in a semicircle. Now again, the sum of angles in a triangle PQR is equal to 180 degrees. So in this case, we say using the triangle PQR. So in this case, we say 50 degrees, then plus 90 degrees, then plus A is equal to 180 degrees. Now 50 it is this angle, 90 is the angle formed in the semicircle, that is PQR, then plus angle A is equal to 180 degrees. So here we have 140 degrees, then plus A is equal to 180 degrees. So to find the A, you take 180 degrees minus 140 degrees. So A, this one is equal to 40 degrees. Now for A is ready. Let us proceed with B. Now again, B, there is a triangle, isosceles triangle inscribed in a circle. Now remember, base angle of this triangle are the same. That is, RMN is equal to NRM, because are the base angles of the isosceles triangle. So again, there is angle MNR, that is a right angle formed in a semicircle. So for B, again we say MNR plus NR, M, then plus, we have R, M, N. This is equal to 180 degrees. So remember, M, N, R is equal to 90 degrees. So in this case, we have 90 degrees, then plus B, again plus B is equal to 180 degrees. So 2B is equal to 180 minus 90 degrees. So 2B is equal to 90 degrees divided by 2 from both sides. So in this case, B is equal to 45 degrees. So again, I hope we are together. Let us proceed with the fourth theorem. So students, this is our fourth theorem, which states that the opposite angles in the cyclic quadrilateral are supplementary. Now supplementary means they add up to 180. That is, the opposite angles in the cyclic quadrilateral add up to 180 degrees. That means SPQ is opposite to QRS. Therefore, adding these two angles, you get 180 degrees. The same as PSR plus PQR, that is equal to 180 degrees, because they are opposite angles in the cyclic quadrilateral. A quadrilateral is a four-sided figure. So PQRS, it is a four-sided figure which is inscribed in a circle. Now students, let us prove this important theorem. So students, consider this construction. So we have a circle with center O, and there are two angles at the center and the two angles at the circumference of the circle. X and Y are at the circumference of the circle, while A and B are at the center of this circle. So remember, required to prove. Remember, we want to prove that PQR, that is to prove that PQR plus PSR, this is equal to 180 degrees. That is according to our theorem. So PQR plus PSR is equal to 180 degrees. So now, proof is as follows. Now, angle to the center is double angle to the circumference. So in this case, we say A is equal to 2x, because A is the angle to the center and X is angle to the circumference. But also, B is equal to 2y. The same reason. B is at the center, while Y is at the point of circumference. But also students, remember, the sum of angles at the center of the circle is equal to 360 degrees. So in this case, we say also A plus B is equal to 360 degrees. That is, the sum of angles at the center is equal to 360 degrees. Now let us substitute equation 1 and 2 into equation 3. So in this case, on substituting the two equations, we have 2x plus 2y is equal to 360 degrees. Now 2 is common in this case. Now we have x plus y is equal to 360 degrees. So dividing by 2, that is by 2, now we have x plus y is equal to 180 degrees. So hence, proved. This shows that the opposite angles in the cyclic quadrilateral is equal to 180 degrees. So again, students, I hope we are together. Now let us do the review question concerning to this theorem. So students, we have this review question, that is, find the angles marked x and y in the following figures. So we have the first circle and the second circle. We are supposed to find the value of x and y for the first circle, but again for the second circle, the value of x. So students, let us start with the first circle. Remember, the opposite angles in the cyclic quadrilateral is equal to 180 degrees. So in this case, we say y plus 80 degrees is equal to 180 degrees. So in this case, y is the same as 180 minus 80 degrees. So y is equal to 100 degrees. You can see how it is simple to find the angle y. Now, but also x plus 110 degrees is equal to 180 degrees, opposite angles in the cyclic quadrilateral. So we say also x plus 110 degrees, this is equal to 180 degrees. So in this case, x is equal to 180 degrees minus 110 degrees. So x in this case is equal to, so that is 70 degrees. So that is angle x. Now let us proceed with b. So here 2x is opposite to x. Now this angle add up to 180 degrees because are opposite angles in the cyclic quadrilateral. So for b we say 2x plus x, this is equal to 180 degrees. So 3x is equal to 180 degrees. Now to find the x, divide by 3 from both sides. That is by 3 by 3. So we have x in this case is equal to 60 degrees. So student, let us proceed with the last theorem in this part of presentation. So students, the fifth theorem states that the exterior angle of a cyclic quadrilateral is equal to the inside opposite angles. So here there are two important angles. The first one is exterior angle, and the second one is the inside opposite angle. So the inside opposite angle in the cyclic quadrilateral, as you can see in this circle here, are the same. That is DAB. That is the angle inside the cyclic quadrilateral is the same as angle BCE, which is the exterior angle. Now again, students, let us prove this important theorem to see whether it is true that DAB, which is the interior angle or angle inside the cyclic quadrilateral, is the same as the exterior angle, that is BCE. Okay, students, let us prove our theorem. So this is our construction. Remember, our interest is to prove that DAB is equal to BCE. So here required, we say required to prove that DAB this is equal to BCE. So now the next is to prove. Now students, DAB plus DCB is equal to 180 degrees because these are the opposite angles in the cyclic quadrilateral. So here we say DAB plus DCB. Now this one is equal to 180 degrees. But remember DAB, that is DAB is equal to x, and this one is y is equal to 180 degrees. That is equation 1. But also BCE then plus BCD is equal to 180 degrees, straight angles. So we say also BCD plus BCE, this is equal to 180 degrees. We said that is a straight angles. So here we have that is y again plus x is equal to 180 degrees. Is called equation 2. So again we equate the two equations. So on equating, that is equating equation 1 and 2 above. So we have x plus y is equal to 2, again y plus x. But remember, our interest is to prove that angle DAB, which is x, is the same as angle BCE. So in this case, we can simplify y and remain with the x. But remember, x is DAB, which is equal to BCE. That is BCE. So in this case, we say, hence proved, the theorem is true. So here we say hence. So let us see an example. So students, that is our example. Find the angle x in the figure below. So the figure is a circle with the cyclic quadrilateral. There is a four-sided figure inside it, and then we are supposed to find angle x. Now I'm sure you remember our theorem 5, which states that the exterior angle that is formed in the cyclic quadrilateral is the same as the inside opposite angle. So I'm sure you know exactly the value of x. And in this case, the value of x is equal to 8. You can read it directly. That is according to our fifth theorem. So again, student, it is my hope that we are together enjoying this lesson. Now here there is an assignment for you. Find the angles marked P, Q, R, and M in the following circles. Of course, that is our circle. That is a circle B, A, E, D. You are supposed to find angle A, P, M, and R. So it is my hope that you can discuss with your friend so that we can find the correct answer in this question. Once again, I hope you enjoyed this lesson of basic mathematics where we were discussing angle properties of a circle. We discussed some theorems that are in this topic. Now, till next time, have a good time.